TLDR, how to set up a strongSwan side-to-side tunnel on Hetzner Cloud. To prepare for this video, I've set up 4 servers, 2 in side A and 2 in side B. The routers are configured as NAT gateways, and the clients are configured to use the router as their default gateway. I've also set up 2 private networks, side A with an IP range of 10.10.10.0 divided by 24, and side B with an IP range of 10.20.20.0 divided by 24. Additionally, you may want to consider a firewall that applies to the routers. You will need to open at least port UDP 4500 and UDP 500 for NAT reversal and internet key exchange. I've pre-set up my terminal. In the first window you can see all 4 servers, and in the second window you can see just the routers. As we haven't set up the tunnel yet, you can see that the ping to the default gateway inside A, so 10.10.10.1, will work on the router inside A and the client inside A, but not on the router or client inside B. You can find configuration examples for different use cases in strongSwan's official documentation. In our case, I will choose the side-to-side PSK authentication configuration example. Install the strongSwan package on your routers. I will immediately enable and start the strongSwan service and navigate to the strongSwan configuration directory. In that, you should find the default configuration. Move to swan control and open swancontrol.conf. At the end of the file, you can see that any .conf file within the conf.d directory is included in the configuration. Move to the conf.d directory and create a configuration file. I'm naming mine side-to-side.conf. Copy the default configuration from the strongSwan website. Update the local address and remote address to point to the routers in side A and side B respectively. I will remove the IDs as we won't use them. Update local TS and remote TS to point to the subnets for side A and side B respectively. Check that the up-down script referenced in the default configuration exists on your machine. In my case it doesn't exist, so I'm using the script distributed with strongSwan. If you don't want to use the default configuration, you can update the ESP proposals here. You can find valid cipher suites in the strongSwan documentation. I will also change the default phase 1 proposals. I will then create a new secret called IKPSK and remove all of the pre-existing secrets. Finally, I will update the configuration on side B to switch local address and remote address and local TS and remote TS. After saving the configuration file, restart the strongSwan service. Check that it's up and running and there are no error messages. Using swan control list_cons, you should be able to see the tunnel that you just configured. Using swan control stats, you can see that the tunnel has not been established yet. This is because the start action for any child is set to none per default. This means that in the current configuration, neither of the peers will actively start the connection. To fix that, we will set the start action to start for side A and to none for side B. After restarting strongSwan one more time, you should now see 1 total IKSA. Checking with IP tables, you should also see that strongSwan has updated the IP tables rules based on the tunnel configuration. Checking with ping again, you can see that we still cannot reach side B from side A. This is due to our masquerading rule in the network dispatcher script. To fix that, we will exclude any IPsec encapsulated packet from this masquerading rule. Doing that will prevent any packet destined for the tunnel from being masqueraded. You can enable all of those changes by rebooting the servers. After the reboot, you should see the updated IP tables rule on the routers. Checking the connectivity again, you should now be able to ping side B's default gateway from side A's servers and vice versa. Congratulations, you've set up your first side-to-side tunnel using strongSwan on Hetzner Cloud. Until next time.